Well, thank you very much, Chloe, for the invitation and the introduction. I'm really happy to be here. And well, the title of my presentation reflects what I think is the status of the space of exploration. I think that we are living in the golden age of space exploration and research, with the space missions that are running or planned to most of the bodies of the solar system, and with a huge international collaboration to achieve these fantastic goals of all these missions. So I would like to talk about that and give a short introduction about the space agencies that allow for all these developments. But I would like to also to use the opportunity to talk about the role of the University of Aberdeen within space exploration and research programs, and in particular in the Mars exploration and research program. Well, there are many space agencies, centers, and mission controls over the planet. This is you see the flags of the different space agencies, centers, mission controls, launch pads around the world. There are more than 70 space agencies, 70, and 14 have launch capabilities. So as you can see, the space sector is all over the world and has grown very fast during the last decades. Actually, the total investment in 2018 all over the world was around $71 billion. And now it's on the order of $95 billion. With the United States, you can see China, Russia, and the European countries as the main investors. So space is moving a lot of funding all around the world. And well, there are not only national investments. In the last years, there has been a big number of companies that have joined the space adventure. So, well, up to the point that there is a company called SpaceX, I'm sure that you have heard about it, that is now able to talk face-to-face to the traditional space agencies. And I will talk a little bit about that in a second. So here I'm listing what I think are the 7 main partners in space at this point. And one of them is SpaceX. SpaceX is a private company that was founded in 2002 with 7,000 employees. And it's based in California, so it's an American company. And well, this is one of the rocket launches that probably you have seen on the news many times. This company is very prolific. Another important partner is the Chinese National Space Administration that was created in 1993 and has the headquarters in Beijing. They also have large rocket capabilities, and they've been on the moon a few times already, and they launched an orbiter to Mars. Another partner is the Indian Space Agency. It's called ISRO. And well, it was created in '69 and has more than 60,000 employees, again, with large capabilities to launch rockets. The Japanese Space Agency is relatively new. It started in 2003, but it still has been very prolific, has been very efficient during the last year with the sample return missions to asteroids. And you can see here the very nice pad in Japan where they launched the rockets to these asteroids. They've been also able to launch missions to a planet. Of course, the European Space Agency, where the UK belongs to, and it's been created in '75. It has a great budget of nearly $7 billion and have launch capabilities in the French Guiana. This is an Ariane rocket launch from Guyana. Roscosmos is a Russian space agency. It was created in '92. It has also around $3 billion budget. And it's very important for Europe because every time that we have to launch a rocket to Mars, we have to rely on the rockets from the Russians. And of course, the National Aeronautics and Space Administration, NASA, that was created in 1985, is the other one, and it has the biggest budget and capabilities and experience. And of course, they have been many missions, and they have many missions on their backs. So this is what I think are the 7 main partners in the space world at this point. As I said before, there are 70 space agencies, but these are the main contributors. So very quickly, I can give you my personal view of the different agencies based on my experience working with them. And be working with ESA in these missions that you see there highlighted, MSAT, Exomars, Forum, and some moon missions, with NASA, with Roscosmos, with United Arab Emirates Space Agency, China, ESA, and of course with the UK Space Agency now with Exomars. So how different they are. And again, this is my personal view after working with them. Well, the European Space Agency is this one is intrinsically different to the others because it's a consortium of national space agencies. So it's a consortium of space of European countries plus Canada, while the other space agencies that you see here, they are national agencies that depend on governments. So the nature of operations of ESA compared with the other is a bit different because of the way that is handled and the way that is directed. So the European Space Agency is very bureaucratic and based, of course, in the consensus of all the countries. And this makes things complicated sometimes and at both high and low level. NASA, the American National Space Agency, depends on the federal government. So there is a clear pyramidal structure that makes things easier sometimes. They work very well in general. They have a lot of experience. They work many times they work under the order of command, which sometimes is good for when you have to accomplish deadlines and deliverables. And they have a lot of experience and resources. So they have the largest budget of all the space agencies, and this makes things easier for them. In the US, there is also a very large impulse of space companies. So space is growing fast in the US. Both ESA and NASA, they are very transparent in the flux of information, and it's relatively easy to work with them. And both agencies, once that they have data, they release it publicly, so everybody can see the data. They don't hide the information. So everything is very well documented and tracked down, and quality assurance is very relevant and important. So working with China, working with China is quite strange sometimes because of the nature, depending on the Chinese government and the military. So it's difficult to work with them because they are very closed, and usually the flux of information is not bidirectional, and it's complicated sometimes. So something similar happened with Russia, although they're more communicative. And I will say that JAXA from Japan, they are close to the NASA way of working. So they have trying to mimic many of the NASA procedures. Although they are a young space agency, so they still lack some experience. One of the basic problems of collaborating with other countries in space is the technology transfer. And then that means that when you have a technology and you want to transfer information to another across the borders, you have to follow a lot of paperwork and reviews, and sometimes even at a military level. And so collaborations many times are complicated. But of course, space agencies collaborate. And in 2018, you can see here, 14 space agencies and 50 countries signed this agreement. It's called the Global Exploration Roadmap, and where they defined the next steps for space exploration in the solar system. And well, in broad terms, the first step will be to develop a platform around the moon that is called the Deep Space Gateway. It will be a kind of an international space station, but around the moon, where we will be able to do experiments and support missions to the moon. Actually, the plan is to land in the moon with astronauts in the near future many times. So the plan right now is to have missions every year or every 2 years from NASA, ESA, and space companies. And next step will be to have capabilities of transportation of materials, because at the end, the goal is to have humans on the surface of Mars. So this is a program that will last several decades, but it has started now. We at the University of Aberdeen participate in this roadmap, as I will explain in a moment. And well, I wanted to, but before explaining that, I wanted to, answer one of the main questions: why collaboration is important? Why is it so important, the collaboration between many people, many different countries for space exploration? Well, and what makes a space mission complicated? Well, just to give you an idea, and of course the amount of time, people, and funding depends on many factors, but just to give you an idea, the space missions are typically the result of something between 7 and plus 20 years of work from idea to operations. So people are working for many years in an instrument. From they have the idea, they submit a proposal, the proposal is approved, then they develop the instrument, they test it and everything. It flies and they are able to operate it. It could be between 7 and more than 20 years. And for example, a project like the Mars Science Laboratory, the Curiosity Rover that I'm sure that you've seen in newspapers and TV, it has involved more than 1,500 people. There's a large amount of people working for this. But as a result of all this work, from all these people, with all this investment, we can achieve things like what I'm going to show you next. I would like to show you an example of the result of this work in a fantastic project that just landed a couple of months ago. This is the landing. I'm going to show you the landing of the Perseverance rover on Mars. The Perseverance rover will address high priority science goals for Mars exploration, including key questions about the potential for life on Mars. And it landed on Mars on February 18 this year. You probably have seen it on the news, and you probably have seen even in TV, but I would like you to see it from a different perspective. So what I'm going to show you now is something.
We are starting to straighten up and fly right.
What I'm going to show you now is something that is not a science fiction movie, of course. It's not an animation. It's showing the images from cameras on board the spacecraft. So I will not talk too much during the video because I want you to feel inside the operations room at the Jet Propulsion Laboratory in California, where this is filmed, and see the reaction of people. This is a around 3 minutes video, and I would like you to enjoy and see the experience. And very importantly, all the images that you will see are real images taken from cameras on board the spacecraft.
Maneuver, where the spacecraft will jettison the entry balance.
Just 1 second. I would like to remove this because then you can see the video better. Yeah.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 480 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface.
This is the altitude of commercial planes. So this is how you will see the surface
Perseverance
of
is
Mars
continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Yeah, again, this is how you will see
OVS
this from an airplane.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TPA is nominal.
We have timing of the landing engines.
Half shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here in safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
It's really amazing, isn't it? Well, it's even more amazing that a few minutes later, the Prof sent this picture from Mars, the first thumbnail. It was just, I think, approximately 2 minutes after landing, we had already this picture, and which is showing the landscape of Mars. Really, really amazing and exciting. Well, we have already landed a few times on Mars, so we have learned how to show off, let's say, and now the rover is equipped with more than 20 cameras. So this is like 4 times more cameras that the Curiosity rover has. So now we can see everything around the rover in every angle. And something very exciting about Perseverance is that just 4 days after the landing, it captured a dust devil that you can see here on the right side of the rover. You will see the movie. Yeah, you can see it here on the right. You see this cloud of dust. This is a dust devil. That was only 4 days after landing. And well, this is telling us from a meteorological point of view that Mars is an active planet. Perseverance has also a microphone. And here, I hope that you can hear the noises. These are the first noises ever captured on the red planet. This is the first time that you can hear something from the surface of Mars. And the noise that you heard is the scratch of the wheels on the sand. Still, there is some noise there that the engineers don't understand, so they are already studying what is producing the noise. It is basically the metallic wheels scratching the surface. Another first from Perseverance will be that it has an instrument on it that will fly from the surface, and that will be the first time that we fly something from the surface of another planet, and we command that from Earth. It's a helicopter. You can see here. The helicopter is called Ingenuity, and it will fly a few meters around the rover. It's just a technological demonstrator, and this is a very important step, not only because it's a first, so the first time that we fly something from another planet, but because of the fact that the surface of the atmosphere of Mars is so thin that it's really difficult to fly on it. So hopefully this rover will fly next week. And actually you can join NASA in this historic event because they will stream it in this web page as you see here. So you want to take note of that. They will have a live streaming next week where you can see the first flight of another instrument from another planet, from the surface of another planet. This is also all very exciting. Well, the reason that I wanted to show you this state-of-the-art mission, so this is a mission that just landed a couple of months ago, is because this is what we hope to bring to Aberdeen. We want to involve young students in this amazing world of space sciences. and we want to be a reference on that. Actually, we started a new department of planetary sciences on April last year, right when the pandemic started. And well, this new department is focused on the study of Earth and planetary sciences. And it will be important the development of instruments for Earth and planetary exploration. And well, the main topics of research are Mars, Moon, environmental research, remote sensing, data analysis, hardware development, and astrobiology. And well, astrobiology itself is a study of the origin of life, its evolution and future in the universe. So in general, this group, this department, this new department in the university is interested in physics, biology, geology, and even law, because we are also interested to know which rules and which laws will apply in planetary exploration and colonization of Mars, for example, or the Moon. But today I will speak only about Mars. And well, I just wanted to mention very quickly about our activities. Currently, we are involved in most of the current and future missions to Mars. In the past, we have participated in important discoveries, like the first detection of liquid water on Mars, methane, nitrogen from the soil, organics, and so on. And we have also been highlighted a few times in the BBC for Mars, and also because we developed a ventilator during the coronavirus crisis based in our space expertise. But the future is ahead, and now at the University of Aberdeen, we are involved in the Exomars Museum. The Exomars Museum will be launched next year in 2022 from Kazakhstan. This is a mission between the European Space Agency and Roscosmos, the Russian Space Agency. And well, I'm the PI of the instrument, and Professor Maripaz Orzano is a co-PI of the instrument, which is called HABIT. And we are both based in the University of Aberdeen, and the instrument will be located in this ExoMars platform. This is how HABIT looks like. By the way, HABIT stands for Habitability, Brine, Irradiation, and Temperature. It's composed by two modules. We can measure UV radiation, temperature of the ground, of the air. We can measure the air wind, dust conductivity, and so on. And we also have this component called bottle, which has a very important goal, which is produce liquid water on Mars. I will come back in a moment about that. Actually, HABIT will be the first European in situ resource utilization instrument in another planet. In situ resource utilization is a word that you will hear in the near future many times, because if we want to go to another planet, we want to go with astronauts to the Moon, we want to go with astronauts to Mars, we need to be able to produce in situ resources. So the idea of HABIT is to produce liquid water, absorbing it from the atmosphere, and producing it in these vessels, and using a property of different salts that we know are existing on the surface of Mars, and that have a property called the liquescence. So through the liquescence, we will absorb the water from the atmosphere and will produce liquid water that can be used in the future for greenhouses or for astronauts. So somehow we try to pave the way for future exploration with astronauts to the planet. And HABIT, it has also a very important goal, which is to study the present-day habitability of the planet. We'll take measurements of very important parameters that we know are important for life on Earth as we know it. So we'll measure the temperature of the surface, the UV radiation, the water activity, and the dust and winds that are important on Earth to transport material. So, well, we will be part of this international effort of planetary exploration and research, and we want to engage students in this effort. So for that, we are planning to start a new master program on planetary exploration and research at the School of Geosciences of the university. And we also will teach a course of planetary sciences within the physics, with astrophysics bachelor's in the School of Natural Computing Sciences. So we want to engage students in planetary exploration and research. And I would like to finish with a homemade video that I made with my children. As you will see, we didn't have a large budget for the video, but I think that it captures very well what Voltaire in Habit will do on Mars. So I will leave you with a video. So this is a proof that outreach can be inexpensive. Well, thank you very much for your time. Please, if you have any questions, I'll be happy to answer.
Thank you very much, Javier. I think the video at the end might have stolen the show there. So thank you very much. We do have some questions. So our first one is from Rob.
Okay. Can I say something just very quickly?
Yes, go for it.
I wanted to mention just very quickly Jeff Wilson. He was from the University of Aberdeen, and he was one of the discoverers of a mineral called macaulite. This is a mineral that has been found only in Aberdeenshire, not in other places on the Earth. And a decade ago or so, it was speculated that this mineral was responsible for the red color of Mars. And as the mineral is formed in the presence of water, they were trying to explain that this could be an evidence that water was existing on Mars in the past. So this is Aquaria at the foot of Benashee in Aberdeenshire. Probably you all know, and it's formed by granite, which has been weathered by tropical climates before last ice age. So maybe Mars is as unique as Aberdeenshire. That's all I want to say. Thank you.
Thank you. No, that's great. That's really, really great to see that connection. I'm pretty sure, well, I was completely unaware of that fact. So I wonder if anyone else who's local to Aberdeen and Aberdeenshire would have known that. So thank you. So yeah, our first question, what is the risk of the rover being damaged upon landing, and how was that risk eliminated?
Well, the risk is always high. You know, I didn't mention that because I didn't want to spend too much time on this. But well, as you know, there is a time delay between the signal when it is. If you send a signal from Mars to Earth, it has a time delay of 7 minutes. So we have to wait 7 minutes until the real thing has happened. So during at time, during 7 minutes, we don't know what is happening with the rover. So this is really crazy because all the engineers that have been working for so many years, they are very worried about that. And well, there are, if you look at the statistics, there is around 40% of space missions that has been failed when they try to land on Mars. So it's not an easy task. It's true that in the last years, NASA has developed this system that you have seen, the Sky Crane. By the way, I can put my video so you can see. Let me see if I can find that. Guys here. Oh, I can see you too now. Yeah. So yeah, and I was going to say, this Sky Crane that NASA has developed allowed that to minimize the risk. But still, there are many things that are taken into account. One of them is the site where the spacecraft lands. This is selected very carefully. So usually, like Gale or like Perseverance, we try to land on craters because the craters are a few kilometers below the surface, and there is some time to react with the rockets in case that we see some problem. And there is more time for deceleration, which is a big problem. There are many computer simulations about what is the best inclination for the spacecraft to enter the atmosphere. So there are a combination of different elements that are taken into account in order to minimize the risk for the landing. But of course, there is always a risk. You have to think that the Curiosity rover or the Perseverance rover, they weigh more, around 1 ton, around 1,000 kilograms. So it's a big monster landing on Mars. It's like landing a big car on the surface of Mars. And additionally, it has very sensitive instruments. You have to be careful with all the instruments on the rover. So it's really difficult. It's really difficult. It's really amazing to see what the engineers can do. And because when you look at the video or you look at the images, you see that it really looks like science fiction.
Thank you. We've had several comments saying thank you very much for this talk. One saying fantastic, it was out of this world. And our next question is, to what extent do you think that having lofty goals is required to drive innovation and discovery, for example, colonizing Mars, etc.?
I have lost your voice, sorry.
To what extent do you think that having lofty goals is required to drive innovation and discovery, for example, colonizing Mars, etc.?
I think it's really good to have this high and these lovely goals. It's really good because it inspires people. Even if you cannot reach the final goal as you want, like for example, taking astronauts to Mars in 10 years or 20 years. But what you have to do that, it creates a lot of technology, a lot of thoughts, a lot of innovation that will be helpful for not only for space, but also for developing technology that will be helpful on Earth. I really think that I had an old professor when I was at NASA that always said, you do what is possible, you do what is difficult, and you try what is impossible. So I think that this is a good way to think about the space. I mean, it's going to be very difficult, for example, to colonize Mars. I don't think that they will be done. I don't think that the population will move to Mars at some point. I see Mars more like a lab, like a place where astronauts can land, where we can do experiments and so on. But I don't think that we should escape Earth to go to Mars. I think that the worst of Earth will be better than the better of Mars, because the conditions of Mars are really, really hard. And so I really think that we should try these lovely goals, these nice goals that will help us to develop a technology and knowledge that will help us not only for space, but also for Earth.
Thank you. And Charlotte has said that that's a great saying from your mentor. So our next one is, how easy will it be to generate oxygen on Mars for extended manned missions?
Well, there is an instrument in Perseverance called MOXIE that has the goal to produce oxygen, actually using the CO2 in the atmosphere and some chemical reactions. They want to produce oxygen. And I mean, I think again, like Habit, these are technological demonstrators. We probably will be able to produce a little amount of oxygen. We'll be able to produce little amount of water in the case of Habit. But what will be more difficult is to create large amounts of it. That's something that we need to investigate. Of course, we can try now. I mean, we have to go step by step. So now MOXIE in Perseverance will do this, will produce oxygen. And then later we have to see how this can be done at large scale. It's not going to be an easy task, of course, but I think it's doable.
Great, thank you. And we have a question from Ailey, who's coming to the University of Aberdeen at the end of this year to do physics, which is really great to hear. She's saying that she has a passion for space exploration. Is that something that she'll get a chance to do? Will she get a chance to do some planetary science?
Yeah, actually, in the new program of physics with astrophysics, we are giving a course on planetary sciences. And so this will be in the bachelor. And you can, if you want more information, I will be giving that course, by the way. But you can contact Charles Wang at the university. He's the one who's coordinating this new program. And yeah, and I will be teaching that one. And then we have what I mentioned, that we will start a new master in January about planetary exploration and research. So yeah, you will be able to contact us and see what we do and get involved if you want.
Great, thank you. We also just had a comment for someone saying that they wish that they were still basically a current student who would be able to be involved. So that's also nice to hear. And our next question is the gravity enough to present physiological problems?
Yeah, this is something that needs to be investigated. One problem with gravity is that it's very difficult, or nearly impossible, to have experiments on Earth simulating the gravity of Mars, especially if you want to do long-term studies. You can simulate low gravity conditions. For example, you can do these zero-G gravity experiments, or you can do International Space Station experiments on time. But they are not the same kind of condition that you have on Mars. On Mars you have like a third of the gravity on Earth. This is really difficult to simulate. So within this global roadmap that I mentioned before, right now we are working with the European Space Agency to have it's called like a biological platform on the moon, where people can do experiments to microorganisms, to different kind of, to do in general biological experiments, to study how the low gravity of the moon can affect the physiology of organisms, even astronauts. And from that, we would try to extrapolate that to Mars. I'm sure that we will have experiments on Mars before the astronauts go in order to test these effects. But first, we will try on the moon, and then from the moon, we will translate those experiments to Mars. But it's very important that once the astronauts go to Mars, we really know very, very well the environment. We really know very, very well what will happen to them. So and no space agency wants to risk on that. And I'm sure that we will have many experiments on Mars before astronauts can go there.
Great, thank you. Our next question is, what will happen to the equipment once the mission is over?
It will wait until we have a Smithsonian museum that takes them to the. I mean, they just stay there, and they will be just buried on dust. Because something very important that I haven't mentioned about Mars is that Mars is really, really dusty. It's a very dusty planet. Actually, if you are familiar with the InSight mission from NASA, this is a mission that was launched a few years ago. I think now it's in the second year. And just today, they decided to switch off the mission in hibernation mode because I mean the power from the mission is from solar panels, and because the place where that mission landed is a place where there are not many winds. The dust that is deposited in the solar panels is preventing the sun to reach them. So the mission doesn't have power at this point, and is waiting for winds to blow up and remove the dust. And this is what will happen to the space missions that are there, like the Curiosity rover, like previous rovers. There will be a lot of dust just covering them, and at some point they will be buried on dust. I'm sure that in the future, if astronauts go there, we will try to recover all these instruments. And actually, something very important is that I'm sure that at some point, when we have astronauts on Mars, they will like to see if there is any microorganism from Earth that was growing inside of these spacecrafts. Because even that we decontaminate, we clean as much as possible, we sterilize the instruments before they go to Mars. Even that we do that, it's really impossible to remove everything. I mean, there are always spores that are latent in the spacecraft. So it will be interesting to see if with the years they are able to survive.
Thank you. Our next question is from Sean. I guess the rewards for science with manned missions to Mars could be enormous, as with the Apollo program. They invented as they went. I assume the Mars mission will be similar in driving science forward.
Yeah, that would be actually one of the biggest controversies of Mars research at this point. There are I think I would say at least two big debates on Mars research. One of them is if there is liquid water on the surface or not, and if it can be created and then evaporated from time to time. And the other one is the presence of methane on the atmosphere. There are measurements that tell us that there is methane in the atmosphere. Then there are other measurements that tell us that it is destroyed very quickly, too quickly, or there is no methane. So these kind of measurements, I think that the only way to have a right answer about the liquid water on the surface or about the presence of methane is just to send astronauts there and have them measuring with devices. It's really difficult because of all the uncertainties that we have in the measurements, that we can really know for sure if there is water or there is methane. There are hypotheses, we can test the hypotheses, but at the end, we cannot promise 100% for sure that there is water or there is methane. On the other hand, there is a very important question that I think that the only way to solve is to go there with astronauts, which is to find life on Mars. I mean, you probably know that the Viking experiment, they have a positive in the search for life in the 70s, and actually the principal investigator of that mission, he thinks that he discovered life, but because it's a big claim, it needs big proofs, and so I think that we really need an astronaut going there and measuring that there is a microbe there. Otherwise, not everybody will believe the experiments because the claims are too big.
Thank you. And our next question kind of touches on what you were speaking about, just the question previously. Will we kind of leave a lot of pollution?
Well, we try not to, especially because there is something called Planetary Protection Panel, a Planetary Protection Panel for this is a panel from the Committee on Space Research, which is an organization that includes all the space agencies and nations that are working on space. This is an international panel which every 2 or 3 years appoints scientists, engineers, and different people from different backgrounds, and they study what are the measures that we have to take in order not to contaminate Mars or other bodies. So every time, as I mentioned before, every time that we go to Mars, we sterilize everything. Actually, we spend a lot of money doing that because it's not a simple task. Especially, can you imagine with this big rover? If you want to to sterilize all the rover with all the instruments on it, this is a lot of money in order to do that. So we try to be as clean as possible. And of course, as I mentioned before, it's impossible to remove everything. There will be some spores or even some microorganisms. It's true that during the flight, you have to survive the vacuum of the space, and you have to survive the heat when you go down, entering in the atmosphere. You have to survive all these big temperature differences between day and night, which are around 150 degrees difference between day and night. You have to survive the minus 200 degrees at night on Mars. You have to survive the UV radiation hitting the surface of Mars because there is no ozone layer protecting the surface. So you have to survive many things, but still there is a risk of contamination. But we try not to do that. Of course, if we go there with astronauts, it will be very, very difficult to not to contaminate something with microorganisms from the body. I mean, you know that we are 60% microorganisms, so we are full of microorganisms in our bodies, and it will be very difficult to prevent all contamination. But we try not to do that. And regarding, and if the question was related to the trust that we leave behind due to the spacecrafts, well, Mars is a big planet, and we don't send so many probes to Mars as to have a big contamination in that sense. So there will be some trust from the rovers there, but it's not a big deal, I will say. And as I said before, at some point there will be a museum storing all them.
Thank you. Our next question is, I've heard that the International Space Station will soon become obsolete. Are you aware of any plans to replace it? Are there any countries planning to send their own space stations into space?
Yeah, well, yes, I know that. I mean, actually, I think that the International Space Station has expired several years ago already, and they've been always. It's very expensive to maintain it, and a big problem is that at some point it could be a risk for astronauts. So the biggest concern at this point is if it's safe to send astronauts to the International Space Station, because I mean, in space, even that the International Space Station was done to last for many years there, I think it's on the limit already. And the problem is that when you are exposed to the space, you are exposed to all kind of radiation from galactic cosmic rays, from the solar particles, the solar wind. So you have a lot of high energy particles hitting the International Space Station, and this is damaging the structure. So and maintaining that is quite expensive. So I think that the last ideas that I have heard is that they want companies, space companies, to maintain and exploit the International Space Station so that they can develop. So because for example, there are several companies like pharmaceutical companies that they can, or material companies that they for them would be interesting to develop materials or different products under non-gravity conditions. And so for them will be great to have the International Space Station as a factory. Of course, they will have to maintain it. It will have to be safe. It will have to be repaired and somehow. But I think that the plans at this point from the space agencies involved in the International Space Station is to rent or to sell the International Space Station to space companies interested on that. There is no plan to have another International Space Station, but there is a plan. As I mentioned in my presentation, there is the plan to have a kind of International Space Station around the moon, which is called the Deep Space Gateway. So there will be another station soon in the next decade around the moon. And it will have a similar, it will be smaller than the International Space Station, but it will be also useful for experiments, also for transfer of materials between Earth and Moon.
Thank you. Very interesting to hear about the kind of almost commercialization of the space station there.
Yeah.
Our next one is, realistically, how long do you think it will be until the first astronauts land on Mars? Loving the mug as well, like so on brand with the topic.
Well, that's a hard question to answer. I don't think that I will see it. I don't know. Probably, I don't know, 40, 50 years, something like that. I think that we will be ready to go to Mars with astronauts. 40 years, probably. Well, I hope I can be old and see it, but I can get that age to be able to see it. But I think that around 40 years or something like that. No, before that, I think it's really complicated. Even that you probably have seen this. You probably have heard Elon Musk talking about sending astronauts to Mars, but I don't think it's realistic. I mean, it's a very difficult task. I mean, the travel from, for example, Perseverance, the travel of Perseverance or Curiosity from Earth to Mars is approximately something between 9 and 10 months, 9 or 11 months, depends. It's like a pregnancy, more or less, and this is because you have a robot, you have a rover, and it's not alive, and it's not a human being, because and then it can withstand with accelerations, so it can go faster. So you can accelerate using the gravity of Venus, for example. You can accelerate the spacecraft, and then it can reach Mars quicker. But with astronauts on it, you cannot have these big accelerations. And because it will damage their health. So that's something that means that the travel will be around 2 years to go from Earth to Mars. Then we have to land there, and landing on Mars is not going to be. I mean, even that you have seen this very nice landing in the video, when you see, I've seen the real test, and the impact of the rover with the surface is quite big. So it's not as soft and it looks when you see it in real. And then of course you have to have a softer landing with astronauts, and then you have to survive there and be ready for that, and then you have to come back, which is important. You have to be able to have the engine working back to Earth and come back. So all this has to be tested very carefully. I mean, and until this is totally done, I mean, I don't think that there is also the problem of radiation. I mean, the astronaut will have to be 2 years exposed to the space radiation, and even that we can shield it, it's going to be difficult. Yeah. So 40 years is my bet.
We'll wait and see. We'll wait and see if you're correct.
Yeah. I hope not, and we can do it later.
Yeah, hopefully it'll be sooner.
Yeah.
If there is a habitation on the moon, do we still need the space station anymore?
Well, that was a debate, actually. People were debating about that topic. Yeah, well, the International Space Station, or the space station, or the Deep Space Gateway in that case, is something that will provide zero gravity. So you can do experiments at zero gravity. It can also be like a bridge between Earth and the Moon, which is one of the important applications of the Deep Space Gateway, because the idea is to have cargoes going to the Moon, but stopping first on the Deep Space Gateway and fueling the spacecraft. So there are some proposals to have like kind of stations, gas station on the Deep Space Gateway that can provide fuel to the spacecrafts, not only in the way to the Moon, but also in the way to Mars. So, but experiments in zero gravity or really zero gravity that can be done in the International Space Station will not be done on the Moon, which it still has some gravity. And so I think that they're complementary, and both can be used to do complementary science.
Thank you. Our next one is, I know the ISS needed to change its altitude due to space debris. If there is space debris around Mars, could the space junk interfere with rovers like Perseverance?
You mean if there is this junk around Mars or around the Earth?
It says if there's space debris around Mars. Oh,
Around
could
Mars.
the junk? Yeah, could the junk interfere with rovers?
Well, space debris is a real problem. It's a big problem, actually. I mean, we see. I mean, if you have a look, you do a Google and look for space debris. It's really amazing the amount of debris that there is on space already. Actually, several holes in the International Space Stations are due to this space debris hitting the structure. So it's really a big problem that needs to be solved, and there are some proposals about how to remove that space debris. If that space debris is around Mars, there will be a problem too. It will be the same kind of problem. The difference, I mean, we've been sending spacecrafts to space since many years now. So it's around 70 years now that we are sending a spacecraft to the space, and in the last year, there has been increased exponentially. So in the case of Earth, it's a real problem because we've been sending a lot of instruments or spacecraft to space. We haven't sent so much to Mars, but if at some point we continue sending spacecraft, that could be a problem too. Yeah. Even they can even hit some of the satellites that are there now, and they're acting as relay of information. So every time that Curiosity sends information to Earth, it's not sending that information directly to Earth. It's sending that to the orbits around Mars, and then those orbiters they send the information to Earth. So yeah, we must be very careful with space debris, and this is I know that NASA is investing a lot of funding now looking for solutions for that.
Thank you. That was the last kind of question in the chat, but I'll kind of hold off just in case anyone has anything else that they'd like to add. I'll maybe ask a question. Would you like to go to Mars? I know you've kind of mentioned the kind of 9 months, all the things you'd have to endure, but if the conditions were maybe slightly more favorable, would you like to go?
No.
No.
I have that very clear. Well, Mars is not a nice environment.
That's fair enough.
Well, actually, as it is, I mean, Mars is the temperature at nighttime is around minus 200 degrees Celsius. At daytime is just a few degrees above zero. Something very interesting that I haven't mentioned in my presentation is you stand on Mars at noon, so at the warmest time in the equator. The temperature difference between your eyes and your feet will be 30 degrees. So
wow.
It's a strange place. It also is very dusty, and the biggest problem is the radiation. I mean, the radiation will kill the DNA in a few minutes. So this is a big problem. This is why I think that it's not so simple. On the other hand, the surface of Mars is covered by perchlorates, and perchlorates are bleach. So the surface of Mars is kind of bleachy, and so it's not a very nice environment. This is what I say, that the worst of Earth will be better than the best of Mars.
Yeah, it's not sounding particularly appealing to me, so.
No, it's nice pictures and everything, but and of course there is no oxygen in the atmosphere, which is very important too. So somehow this is what I think that the colonies will be. I mean, we will have small labs in the future or something like that for astronauts, and they will be like a place for research. But I don't think that will be a place for living. We have to. Yeah, I think it's better that we take care of our planet.
Yes.
No, you don't want to.
Yep. Oh, we've got one more question. What a fantastic presentation. Many exclamation marks. One final question. will a manned trip to Mars be commercial or driven by politics/nations?
The first one, or the first one probably will be done by a space agency. It could be that in collaboration with space companies. I think that space companies like SpaceX are increasing. I think that really SpaceX is helping to sort this 40 years period that I think that it may take. I think that companies like SpaceX are investing a lot of effort and funding, and they probably will reduce that time period until we go to Mars with astronauts. I think that at some point, I think that the first astronauts will be NASA and a space company or something like that. And then after that, I can imagine that the SpaceX or other companies will like to exploit that, and I'm sure that they will try to have some tourists to Mars. I think that soon that will be done with tourism in the moon. But we must be very careful because safety is very important, and we don't want that the first astronauts that go to Mars or to the moon, the first tourist astronauts going to the Mars or the moon, die on the first trial. So we must be very careful with that, and especially we need to be aware that they have to return back. So we need to provide all the resources so that they can come back once that they land on Mars.
Great, thank you. Just again, if there are any other questions, we do still have a little bit more time, so please feel free to pop them in. If there aren't, yeah, someone's just shown us just saying very interesting presentation, and agree that we need to look after our planet first, which, yeah, I agree with, which is also, I think, a really nice note to kind of conclude on, that it's great, obviously, to have all this exposure to new worlds and new locations, but obviously we're still on Earth for the time being, and taking care of our own planet is very, very important.
Yeah, something important that the space many times provides for solutions for Earth too. Yeah. And a lot of technology that has been developed for space has been applied later on Earth, and many of them to medical applications. And well, and I really think that in doing Mars research doing Mars research is very important, in the sense that I didn't mention that in my presentation, but Mars at some point, we know that for sure, that Mars at some point had a lot of water, and it was fully covered by water. Actually, something people believe, some theorists believe that, or there are some hypotheses that theoretical studies that say that there was even more water than there is now on Earth. So that means that Mars lost the water somehow, and that at some point, both Earth and Mars, we were sharing the same environment. We were both a rocky planet with a lot of water, with an atmosphere, and so on. So we want to know what happened to Mars. We want to know if something like that can happen to Earth. So something important about investigating Mars is to know if Mars could be the fate of our planet or not. So we want to know why Mars lost all this atmosphere and water. And this is an important, this is a very important question that we need to answer. We don't want to be a new Mars in the future.
Thank you. We've got a couple more questions. Can you see Earth from Mars?
Yeah, sure. Yeah. You can see it, and you can see it like a big star that is not ticking, and is kind of reddish. Yeah.
That's right.
If you write where is Mars on Google, what is Mars today, you will find it. You can just look through the window. Cool. Summertime is a period to see it. Yeah.
And Charlotte said, "Wow, do you therefore think we will discover previous life on Mars?"
That's the $1 million question, isn't it? Well, I think that if there was life on Mars at some point, which is possible, we know that Mars has was habitable in the past, in the sense that it had the conditions for life as we know on Earth to be there. So we had conditions on Mars in the past that would allow microorganisms on Earth to be there. So if at some point there was life on Mars, I think that it could be hidden under the surface. What we see on Earth is that it's really hard to kill microorganisms. And people have been doing boreholes kilometers deep, and they still find microorganisms there. So I really think that there are many microorganisms that are very resilient. And if they were alive at some point, if there was life at some point on Mars, I think that there must be some life under the surface. That's my bet also. Not on the surface because of the radiation and harsh conditions, but it could be hidden within caves or under the surface of Mars. We know that under the surface of Mars the temperatures are still good, and we know that there can be liquid water under the surface, so they can be having all the nutrients that they need to survive.
Thank you. And just to reiterate, got another question. I work at Aberdeen Science Centre, and I'm currently writing a script for a new show about our solar system. Do you have any cool facts about our solar system?
Oh, cool facts. Well, there are many cool facts, but like the one that I mentioned before about Mars, I think that this is very interesting, that you can stand on Mars, and the difference between your feet and the temperature difference between your feet and your eyes is more than 30 degrees. Well, it's very interesting to see how water behaves under the different conditions, and or how at the end a planet like Mars or a planet like all the satellites around Jupiter or around Saturn, they don't have really an atmosphere. So what is interesting is how water behaves under these vacuum conditions. On Mars, for example, we think that brines form at night time, and then as soon as the sun rises, they evaporate immediately, so like if they were boiling, and that create marks on the surface that we think are due to this evaporation. Well, if you send me an email, I can send you some cool facts. We can discuss about that if you wish.
Great, thank you. And yeah, I think maybe just to conclude there, that was a really, really fascinating presentation. I don't know about many others who've attended, but most of my knowledge and experience of space and Mars comes from films. So it was interesting to kind of get a real life insight into kind of what's taking place and just to be more knowledgeable about it. So thank you so much for taking the time. We're getting lots of comments saying thank you. I hope you can maybe see some of the kind of funky emojis that we've got there as well. Yeah, it's been a really, really interesting presentation. Thank you for giving up your time.
Thank you very much. You know, I can tell you a funny fact now that you mentioned movies, just very quickly, is that, for the movie The Martian, you probably have seen The Martian. So the writer of the book, he sent me a few years ago, he sent me an email, and he asked me if I had read the book, because he knew that I was studying environment of Mars with curiosity. And then I told him no, and then he sent me the book and asked me if I can send him some advices about how to improve it and so on. And then when I started reading the book, I saw that there was a big storm that was destroying everything in the camp. And then I told him that was wrong, because you cannot have this kind of big storms on Mars. And then he told me, and then I told him perhaps you can write a new version with a new introduction. And then he said, "Oh, sorry, I should have known you before, because I signed a book. I signed a contract to make a movie of the book."
That's a very amazing connection to have. I feel like I hope you got like a sneaky invite to like the premiere or something of that. That would be pretty cool.
You know, I invited him to come once to our campus, but he, you know, interestingly, he told me that he's afraid of flying.
It's not quite what you'd expect from someone who's written something about space, but
Oh,
fair
no.
enough. I mean,
That was in-
other ways to travel, get across the sea on a boat, perhaps, maybe instead.
yeah. It's a time machine. That
Yeah.
sort of space.
Well,
Well, thank you very much, hope you for being there, and I hope that was not too boring.
no,
and hope that you'll enjoy.
words such as very, very interesting, fascinating, excellent, amazing, inspirational are all in the chat. So I think a lot of very, very positive comments from people who've found it very interesting today. And thank you to everyone also for joining us. We are almost at the end of our event program, but we do still have another 3 taking place, 2 scheduled for next week. So we'll hopefully see some people at some of those. Yeah, and thank you again, Javier, and thanks to everyone.
Thank you very much.
Enjoy the rest of your evenings or afternoons or mornings,
Sure.
maybe, wherever you are. Thank you. Bye.
Thank you very much. Bye-bye. Thank you.